Welcome to Bhava Jnanantara. I am Chidanand Mugali, and let's float in the ocean of knowledge. In our daily lives, we use numbers for various things like managing money, figuring out distances on a map, or keeping scores in game. Numbers are all around us. This class is the start of our exploration into math, beginning with the basics of numbers and their types. Whether it is dealing with time, money, distance, or scores, we will dive into the fascinating world of mathematics together. Dear students, let's explore the fundamental role of the numbers in our understanding of the world. Numbers are not just symbols on a page, they are abstract mathematical entities that form the backbone of our mathematical system. They play a crucial role in representing quantities, measurements, and values. In mathematics, numbers are like the building blocks that helps us make sense of the world around us. Whether we are counting objects, measuring distances, or analyzing data, numbers are the language we use to describe and quantify our observations. Consider this: in science, numbers are used to express physical quantities like time, distance, and temperature. Engineers rely on numbers to design structures, create algorithms, and solve complex problems. In economics, numbers helps us understand and analyze financial data, make predictions, and make informed decisions. Numbers are not confined to the realm of academia, they are part of our everyday lives. From budgeting and shopping to cooking and time management, we use numbers constantly without even realizing it. They are the tool we use to navigate the world and make informed choices. So, as we delve into various mathematical concepts, remember that numbers are not just abstract symbols. They are the foundation of our understanding of the world, influencing everything from scientific discoveries to the decisions we make in our daily lives. Now, let's connect this understanding of the numbers to the different types of numbers. We have just discussed now, numbers are essential in various fields and aspects of our lives. Well, these numbers can be categorized into different types based on their properties. Firstly, we have natural numbers, which are the positive integers starting from 1 and extending infinitely. They are the numbers we use for counting. Then we introduce whole numbers, which include 0 along with all natural numbers. Whole numbers helps us represent quantities when counting starts from 0. Moving on, we explore integers, which include positive and negative whole numbers along with 0. Integers are crucial in representing situations involving gains and losses or movement in positive directions. And rational numbers come into play when we talk about fractions, where we can express numbers as the quotient of two integers. This includes decimals and either terminate or repeat. On the other hand, irrational numbers like the square root of 2 or pi cannot be expressed as fractions. Their decimals expansion go on forever without repeating. Now, when we bring all these types of numbers together, we get real numbers. Real numbers encompass everything from integers and fractions to irrational numbers. They form the complete number line that we use in various mathematical operations. Let's know the type of numbers one by one. First one is natural numbers. Natural numbers are a fundamental set of positive integers that begins with 1 and extends infinity. These numbers are the foundation of counting and ordering, forming the simplest set in the number system. The key characteristic and properties of natural numbers is it starts from 1 and that sequence continues indefinitely like 1, 2, 3, 4, 5, 6 and so on. Natural numbers are positive integers greater than 0, representing the concept of counting objects or elements. They are primarily used for counting and ordering items. For example, if you have 5 apples, you would use the natural numbers 1, 2, 3, 4, 5 to count them. Natural numbers serve as the building blocks for other sets of numbers, such as whole numbers, integers, rational numbers, and real numbers. They are fundamental in various mathematical operations and provide the basic for understanding quantities in different contexts. The next type of numbers we can explore is the set of whole numbers. Whole numbers include all the natural numbers along with 0. Let's delve into the key characteristic and properties of the whole numbers. Whole numbers encompasses all the natural numbers 1, 2, 3, 4, 5, 6, so on, and include 0. Since 0 is included, whole numbers are non-negative integers. Similar to the natural numbers, whole numbers are used for counting and representing quantities. Whole numbers do not have fractional or decimal part. They are whole non-negative integers. Whole numbers are often used in various mathematical contexts, particularly in counting and arithmetic operations. The progression from natural numbers to the whole numbers is a natural extension that includes the concept of 0, making it a broader set. These numbers continue to lay the groundwork for the more advanced concept in the study of the numbers. The next type of numbers we can explore is the set of integers. Integers include all the whole numbers along with their negative counterpart and 0. Let's delve into the key characteristics and properties of the integers. Integers include all the whole numbers 1, 2, 3, 4, 5, 6 with 0, as well as their negatives -1, -2, -3, -4, like that. So on, that goes up to infinity. 0 is also considered an integer in this set. Integers do not have fractional or decimal part. They are whole numbers, either positive, negative, or 0. Positive integers represent counting in one direction, while negative integers represent counting in the opposite direction. The set of integers extends infinity in both positive and negative directions. Integers are fundamental in various mathematical operations, particularly in arithmetic and algebra. They provide a way to represent situations involving gain and losses or movement in opposite directions. The progression from whole numbers to integers further expands our understanding of numbers and prepare the groundwork for the more advanced mathematical concepts. The next type of numbers we can explore is the set of rational numbers. Rational numbers include all integers and their fractions where the denominator is not 0. Let's delve into the key characteristics and properties of the rational numbers. Rational numbers can be expressed as the ratio or fraction. Integers are a subset of rational numbers. For example, 5 can be expressed as 5 by 1. And rational numbers can also be represented as terminating or repeating decimals. The sum, difference, product, and quotient of any two rational numbers are also rational, except division by 0. Rational numbers are versatile and are used in various mathematical operations and applications, including fractions, ratios, and proportion. They bridge the gap between integers and the real numbers, providing a rich set of values from mathematical analysis and representation. The next type of numbers we can explore is the set of irrational numbers. Irrational numbers are real numbers that cannot be expressed as the quotient or fraction of two integers, and their decimal expansion are non-terminating and non-repeating. Let's delve into the key characteristics and properties of the irrational numbers. Irrational numbers cannot be written in the form of a by b, where a and b are integers and b cannot be 0. Additionally, their decimal expressions go on forever without repeating. Common example of irrational numbers include the square root of non-perfect squares, for example root 2, root 3 and so on. Together with rational numbers and irrational numbers make up the entire set of real numbers. The decimal expansion of an irrational number is infinite and lack of predictable pattern. Irrational numbers add another layer of complexity to the real number system, coexistent with rational numbers to form a complete and diverse set. Their inclusion is essential for a comprehensive understanding of mathematical concepts and the representation of quantities in various contexts. The next type of numbers we can explore is the set of real numbers. Real numbers include both rational and irrational numbers, forming a comprehensive set that encompasses all possible values on the number line. Real numbers include rational numbers, they are fractions, and irrational numbers, those that cannot be expressed as fractions. The set of real numbers is vast and includes integers, whole numbers, decimals, fractions, and more. Real numbers are closed under addition, subtraction, multiplication, and division. The result of any of these operational between two real numbers is also a real number. Real number can be represented on the number line, providing a visual way to understand their relative magnitudes. Real numbers are used in various mathematical disciplines including algebra, calculus, geometry, and more. The set of real numbers forms the foundation of mathematical analysis and served as the basis for many mathematical concepts and calculations. It provides a unified framework for representing quantities in a wide range of contexts. So, as we explore these types of numbers, remember that each category serves a unique purpose in solving different kinds of problems and describing deserved situations. The richness and diversity of the number system enables us to model and understand a wide range of phenomena in the world around us. As we told earlier, your success is our mission. Welcome to Bhava Jnanantara, where learning is an adventure. Thank you one and all.